Marhaban and welcome to everyone. We are now on our third edition of the Science Talk series at SeaWorld Research and Rescue. And I want to say again that this initiative is developed in a partnership with the Environment Agency Abu Dhabi, EMIRATES Natural History Group Abu Dhabi, the Natural History Museum Abu Dhabi, and NAUTICA Environmental Associates. And as usual, they are here in the audience, so thank you so much for your support. Okay, so tonight we will extend our interest outside of the underwater world to discuss about climate change. I know that it's a topic that we hear a lot these days with the COP28 starting very soon next door in Dubai. But it seems indeed that we've been hearing about those issues coming from climate change, global warming, climate disruption for quite some time now. But I'm sure that it's still quite a complex and somehow intangible notion for some of us present here. So I hope that tonight you will have some answers and maybe understand a bit better how well those impacts that we're talking in those big conferences like COP28 are actually very close to us and will impact us very much directly. I just wanted to talk about, obviously, since the Kyoto Protocol in 1997, so this was the COP number 3 already. A lot of discussion has been done around climate change and what to do to fight or to try to reduce the impacts of climate change. And just as a reminder, but I'm sure we will talk about that later on, in the Paris Agreement adopted in 2015, one of the objectives was to hold the increase in the global average temperature to well below 2 degrees Celsius above pre-industrial levels. But I don't know if you've seen that just last week. Actually, for the first time, last Friday, the global average temperature was more than 2 degrees above the pre-industrial levels, according to preliminary data from the Copernicus Climate Change Service based in Europe. So we have a lot to do still, and I think a lot to talk about all the impact and adaptation to those impacts. And I guess this is what we will be doing today, later on with a panel discussion, looking at how to adapt and how as a community we can just get ready, prepared for what's coming, the impact from climate change. All right, I'm not going to speak any longer. We have two absolutely brilliant guest speakers tonight. And I'm very, very glad that they accepted and they found the time to come and speak to us, because it's a very busy time for them, especially with that COP coming. So this is Dr. Diana Francis here. She will start with a talk for us. And Ms. Shaemma Mebwana, from the ministry, who will join us, and we will have a panel discussion, and we will have open question from you afterward. So first, Dr. Diana Francis. It's really an honor to have you here. Dr. Francis is an internationally renowned atmospheric scientist with a PhD from the Sorbonne University in Paris. She has a lot of experience from very high level quality institutions in Europe. And she joined Khalifa University 3 years ago in 2020. And she is the head of the Environmental and Geophysical Sciences Lab, where she significantly contributes with her team to the development of Khalifa University's and UAE's research portfolio in climate and atmospheric sciences. I think we are super lucky in the UAE to have her here. So obviously, she will tell us maybe more about her role in the climate data and modeling work that she's doing at the UAE Climate Change Research Network with the ministry. But I will just leave the floor to you and hope you enjoy the talk. Thank you, Diana.
Okay, good evening, everyone, and thank you for making the time to be with us late today. So I'm a professor and climate scientist at Khalifa University. I'm the head of NGOs Lab, where we work on environmental science, and we try to apprehend all these issues that are unfolding under climate change. So tonight I'll be talking about what is climate change, in fact, how we can actually measure it, how we can see it, how we can apprehend what is happening around the world, but especially in our region. Okay, so as climate scientists, you can imagine us as the doctors of the planet. So we monitor the planet Earth as the doctors monitor the health of human beings. So as we said, the climate scientists, they monitor the health of the planet, and for this they measure the vital sign of the planet Earth. One of those signs are the temperature, okay? So since 1960, they noticed that the global temperature of the Earth is actually increasing at a very, very high rate that they haven't seen in the natural variability that existed in data before this period, okay? Until now, this global temperature increase, it reached 1.5 degrees Celsius, okay? In some days, like last Friday, 17 November, it reached 2 degrees Celsius above the pre-industrial level. So other signs of the health of the planet that scientists can measure is actually the sea level rise. And here again, they have been measuring increase in the level of the sea, this from satellite observations as well as from measurements that are on coastal areas, so we can see how much the sea level is varying. And here again, the numbers are huge. 12 centimeter, the sea level rise reached in 2022. 12 centimeters may seem little for you, but for sea level, it's really a large value, because this means the floodings are more easy to come inland. The storm surge will have much higher impact. And if we look globally, this is how the sea level rise is distributed around the globe. So as you can see, the red spots are the areas where the sea level rise is increasing very, very high compared to the yellow and the white areas. So we can expect that some areas can actually experience the damage of sea level rise faster than others. So scientists then started to ask the question, why the sea level is rising? And when we combine this with the data that is coming from, let's say, the Arctic, so the Northern Pole, over the year, you will see in this animation how the sea ice extent is actually shrinking at a very high speed. So we are expecting that in 2050, the Arctic Sea or the Arctic Ocean will be free from any sea ice. Okay, and this, of course, has major impacts on the marine life and on the sea level around the world. So even if this will happen in the Northern Pole, the impacts will be felt globally, especially in coastal areas. This is also the case for Antarctica. You know that Antarctica is the largest freshwater, let's say, fridge for the Earth. So we store the ice in Antarctica. And this is also starting to melt. And here there are some what we call tipping points, meaning at certain point there are some events that can happen, and after that we cannot get back to the initial conditions. One of those tipping points that are feared in Antarctica is actually the collapse of all this western region, we called West Antarctica. Why? Because the rate of melting from the ice shelves and the glaciers is very consequent, and it might, collapse by detaching completely from the rest of the continent. So the planet got examined by the doctors, and what are the signs? The planet is sick, right? Temperature is very high, sea level is high, the levels of CO2, so carbon dioxide, are high, and all the parameters are actually in the red zone. So then scientists start to combine several data to understand from where this is coming. Okay, normally the planet should be running on a natural cycle, which is healthy without issues. So from where this is coming, and here where they started to combine the human activity with what we are seeing in the temperature. And we see here the perfect correlation with the increase in temperature and the corresponding human activity. So what we mean by human activity here? We mean that the activities that we do in our daily life, they are actually producing some pollutant. Okay, what are these pollutants? They are mainly greenhouse gases and aerosols. Okay, so why these greenhouse gases and aerosols are so harmful? Because they stay in the atmosphere for a very long time, between decades and centuries. So once they are emitted, once they escape from any process, any industrial process, or any car, or any airplane or ship, they stay in the atmosphere for 100, 200 years. It means that now the levels that we are seeing now of these greenhouse gases, they were emitted in 1920, 1930, and they got increased as we developed our economies and industries. So by nature, these gases, they like the heat. They are greenhouse gases. They like to keep the heat from the sun. So once the sun radiation enters the atmosphere of the Earth, and they are captured by these molecules, okay, they stay here. They like to interact with infrared radiation of the solar radiation, so that's why they are causing a warming. It's like you are putting a puffy coat, okay, on the planet. So imagine you are putting this around the planet, and so the warmth is not able to escape anymore to the outer space, okay? All the warmth is actually staying in the atmosphere and warming again the Earth, because now it is insulating the Earth because of greenhouse gases. Okay, so let's look more into details into greenhouse gases. So here are the concentrations of the main greenhouse gases. There are others, but these are the main ones. And here we have the temporal scale. So we can see that the major contributor is CO2. The second one is methane. And then we have N2O. And if we look from where these are coming, okay, which activities are actually contributing to this? So this, you can see it on this graph, and here we have mainly the CO2 is coming from fossil fuels and industry. Whenever and wherever we burn fossil fuels, it's a chemical reaction, it will produce CO2. The other activity that is contributing to the high level of CO2 and methane is the land use and land cover, and the decrease in the coverage from forest. Because as you know, in order to plant crops, for example, or any plant that we want to use for food or for industry, we remove forest, we put in place this kind of crops. So over time, the area that is covered by forest decreased, and the area that is covered by seasonal crops increased. The seasonal crop doesn't take much CO2 as the forest because they are seasonal, so they are cut, and the greenhouse gases can escape again to the atmosphere. So the forests are really important because they represent the sink of CO2 from the air to the soil. If you want to remove CO2 from the atmosphere, we need to plant trees so they can actually suck out the CO2 from the air. Then the research and the investigation continued, and here these graphs are showing what are the countries that are most contributing to the observed CO2 concentrations. Because as you can imagine, in conferences like the Conference of the Parties, COP, these are conferences that are held between countries, and so each country needs to know from where the emissions are coming, and because later there will be some discussions around finance, around efforts around donation to adapt to climate change and all this. So they need real data about the contribution. And these are the data. So for instance, here you can see at the top, we have China from Asia, India, Brazil, Indonesia, Russia, Japan. From the Middle East, we have Saudi Arabia and Egypt, and so on. So now if we look by across the supply chain, so meaning what are the activities that are giving a lot of CO2, it comes on the top, the land use and change, and all the processes related to the food chain. So this is in order for the countries to know on which sector they can focus in order to reduce the emissions. Okay, so now let's look into the different contributors to the warming. So as we saw that the human activities, so any activity related to industry or traffic or agriculture will produce what we call anthropogenic greenhouse gas and aerosols, meaning something that the man is producing. So these here, they will contribute differently to the final budget of temperature. So on this axis here, you have the contribution in degrees Celsius to the temperature, okay? So whatever is red, meaning they are contributing in positive way, and whatever is blue, they are contributing in a negative way, meaning they are cooling. And the other input data to keep in mind is that the lifetime of greenhouse gases is very long, as we said. And the lifetime of the blue ones, the ones that are contributing to the cooling, is actually short, hours or weeks, okay? Although they are both coming from this activity, let's say, from the industry, the greenhouse gases will stay centuries and decades, but the aerosols, which are these in blue, will stay hours or weeks. This is important because it caused a dilemma in the scientific community, because if we do efforts actually to reduce these emissions, okay, what we'll be doing will be removing very fast the aerosols that are actually cooling a little bit. They are masking now the effect of greenhouse gases, but we can't remove this because their lifetime is very long. Okay, so this is to say that the efforts to reduce emissions from the human activity in the first few years will lead to additional warming until after we catch on and we start decrease both. Okay, so where we stand now, at present, if we take the global average temperature of this year, we are here, and it's expected to reach 1.5 degrees Celsius on an annual average. I told you in the beginning that in specific days, we can actually surpass this value. But when we take the annual average, we are expecting that 1.5 degrees Celsius be reached in 2030. And then we use different scenarios in order to project how this temperature will evolve in the future until the end of the century. And these scenarios depends on the engagement and the pledges of the different countries to reduce their emissions. So the IPCC, which is the International Panel on Climate Change, that is a UN body composed of scientists that they study the climate science and the science behind climate change. They put in place several scenarios, and you can go from the most optimistic one, meaning that all the countries, without exceptions, they are doing a lot of efforts to cut emissions. This will lead us to this scenario in blue. The most pessimistic one is the one where we continue business as usual, no change to the activities or emissions, and this will lead to 4 degrees Celsius warming of annual global temperature. So this value now, when we average over the globe, it doesn't tell us really what's happening in different regions. So it's always good to look into how this value is spread out around the globe, okay? This map here is showing you the temperature change relative to the global average, meaning which regions are warming fast and which regions are warming slowly compared to the global average. So the regions that are warming very fast compared to the global average, they appear in red, and this is mainly the northern hemisphere. If you look into our region here, values of meaning that this region will be warming twice as faster as the global average. So why this is important? Because if we know that a region is warming very fast, like the Arctic, for example, it's warming 4 times much faster than the global average, it means that we have less time to actually take actions. We have less time to stop the process from reaching a tipping point. So that's why also we consider the rate of change in different regions. And this is also important because on smaller time scale, this warming is actually leading to what we call extreme weather. We know that when we give any system excess of energy, any system will try to reach equilibrium by evacuating this energy in a way or another. So the atmosphere or the Earth system as a whole, whether it's ocean, atmosphere, ice, and land, how they do this, how do they evacuate the excess of energy? By extreme events like cyclones, hurricanes, droughts, if it's too dry, floods if it's raining too much. So the extreme weather events we've been seeing, I think since 2010, the frequency of those events around the world has been increasing dramatically. And what is the physical explanation behind this? It's not only a hypothesis, it's something that we can understand because we know the physics law, the law of physics that govern the climate. So when we warm the oceans, the water, of course, what will do? It will evaporate. So the rate of evaporation is increased because of the increased temperature. So with more evaporation, we have more moisture in the atmosphere. In addition to that, when the atmosphere is warm, it can hold more water vapor. This is also known. For instance, the same volume of a bottle, or when it is warmer, we can put in it more moisture. So first, these two, we are evaporating more, plus the atmosphere can hold more moisture because it is warmer. And we are also evaporating more from the land, from the crops. And when all this moisture and energy is in the atmosphere, the result will be extreme weathers. This is a graph showing the previous climate before the access of energy that is done to the atmosphere and the new climate. So here we can say that even if it is a small shift between the two climates, but here the impact is actually bigger because we are shifting toward hot climate. Okay, let's now focus on the Middle East or the Arabian Peninsula area. So we saw that this region is warming 2 times faster than the global average. And here we can see it clearly. In black, we have the curve for the global average, and the orange one is for the Middle East. So it's really, it crossed actually the global average value. Regarding the sea, I think the only sea we have is the Arabian Gulf, and it is naturally it's a very warm and saline water in the Arabian Gulf because it's very shallow. We don't have much depth here, so that's why any increase in temperature for this Arabian Gulf area, it can actually lead to high increase in salinity and in water. For example, it was estimated to 0.63 degrees Celsius per decade during the last 2 decades. And again, here it's a hypersaline water that can actually damage the marine life. Now, if we look into the climate projections about the Arabian Peninsula and the Middle East, what they tell us, what the future looks like for this region. So here we are taking the most pessimistic scenario from the IPCC, and the projections are showing that we can have an increase by 5 degrees Celsius per decade between 2050 to the end of the century. Okay, and we can also project the precipitation that are going to happen globally as well as over the Middle East. And in terms of precipitation, the Middle East is kind of divided into 2 regions, with one that will be experiencing droughts and dryness, and the southern part that will be experiencing increase in the amount of rainfall. Why? Because with global warming, as we said, we are evaporating more water, and so the tropical regions are expected to expand to the north and to the south because of the high rate of evaporation. When we saw these figures in the projections, we tried to look into the trends to see if we can see the signal of increased precipitation in the past data. Okay, so this study focused on the rain that is coming from a convective system during spring here over the UAE and surrounding countries, and indeed we do see increase in the frequency of these systems, as well as increase in the amount of rain that is coming from these systems. Some events related to the northward excursion of tropical cyclones we've seen in the last 3 years here. Actually, the 2 cyclones that succeeded to enter the Sea of Oman here and make landfall and impact the UAE were the Gonu in 2007 and Shaheen in 2021. Before these 2, in all the history of tropical cyclones in the Indian Ocean, there were no cyclone making landfall on the eastern coast of the UAE. So when these events happen, and I'm sure everyone remembers all the damage that was caused by these cyclones in Fujairah and Oman, so we investigated the reason why these 2 cyclones succeeded to enter here. And the result was that the warming actually over the land the warming that was present during these two episodes over land acted like a drag to these cyclones to come over our region. Now, another impact of climate change is, of course, sea level rise, and this is important for coastal areas and for areas like the UAE and the other countries in the region. I'll be showing here several maps of projected sea level rise and what will be the impact on population, how many of the population we will need to move due to the projected sea level rise from coastal areas. So the light blue is for the optimistic scenario and the dark blue is for the pessimistic scenario. So here you can see these are the country, the Northern Gulf, like Kuwait and Iran and Iraq. 38% of the population may need to move by the end of the century from their place because of sea level rise. These are the data that we obtained for the capital of the UAE, Abu Dhabi, where we are, for Dubai, for the other countries, Bahrain and Qatar, and this is for Kuwait. Another aspect of the global warming impact on the marine life this time is the expansion of the dead zones in the seas. Okay, what are dead zones? These are areas where there is no enough oxygen for the fish and all the marine life to continue to live there. So they just simply move from this area. These areas are empty from any marine life. Okay, because there is no oxygen. So there is one just here in the Gulf of Oman, and it has been expanding. That we think the global warming, but also the increase in salinity, because when we evaporate water from the seas, the salt will stay. So the water becomes more salty, and this is not healthy for the dead zones. Okay, so after this talk about the causes and the impacts, of course, as you know, for each problem there are solutions, and even if the climate crisis is a very complex problem, but there are solutions for it. Okay, one example we can mention is, you remember maybe the problem with the ozone hole that happened in the 1970s. So the ozone layer that is protecting us from the ultraviolet radiation was actually depleting, meaning that not enough ozone in this layer is present anymore to block the ultraviolet radiation. The same story happened with this, and the same investigation scientists did. The same COP happened with the Kyoto Protocol resulting from it. So what happened? Scientists discovered that the CFC gases that we used to use for air conditioning system and fridges, they were actually able to reach the stratosphere, to reach this layer. It's a layer very high in the atmosphere, and interact with the ozone and make it vanishing. So they decided, okay, we stop the use of the CFC gas. And this is what happens. And now the ozone layer is actually recovering, and the rate of recovery is 80% now. And we are expecting a complete recovery by 2040. So this is to say that some examples exist in the past while dealing with complex issues like the climate change. So in terms of solutions, I can put them in three categories. The first one is mitigation. Of course, as we said, we need really to do whatever we can to decrease the emissions. This is what we call mitigation. So we are on one path. We need actually to mitigate and deviate from this path. The second one is innovation, because this will help us with decreasing the emissions by creating new technologies, new processes in industry that can capture the CO2 before it escapes to the air. Or innovation also is important to remove the greenhouse gases that are already existing in the atmosphere. So we can think about technologies that can capture and remove the greenhouse gases from the air and store them in other type of matter, solid or adaptation. Adaptation is very important because, as I mentioned earlier, the levels of warming that we are seeing now is the result of emissions that happened since 1950 or 1960 because of the long lifetime of greenhouse gases. So the efforts on mitigation and innovation will actually give results later this century because of the lifetime of greenhouse gases. And we need to come to the evidence that we need actually to deal with the impacts of climate change for some years, even if we are doing mitigation. In parallel, there will be need for adaptation, and this will pass by especially adapting the coastal areas, adapting the urban planning, the infrastructure if we are getting more flood events, heat waves, adapting the cities in Europe to more heat waves in summer to protect the public health and the human. So these are the solutions that we can think about, and they all fall under the 4 R's. The 4 R's for reduce, we reduce greenhouse gases. Remove and repair, so removing what's existing in the air and repair what is damaged in the ecosystems, and build resilience among the cities and among the communities. And a take-home message that collective actions bring really effective solutions. So even small actions at the level of each person, each family, each group, each community can actually at the end lead to significant impact. That's all from me tonight. Thank you so much for listening.
Thank you so much. This was very informative, and I guess you learned a lot. So thank you so much, and I really like your last message indeed. And I guess we will jump on this message now, and I will call on stage Ms. Shaemma Mebwana. Shaemma is a young climate change analyst for the Ministry of Climate Change and Environment. And Ms. Mebwana brings a wealth of expertise and a nuanced perspective on climate action and preparation in various global regions in response to climate change. Indeed, she has been transforming her passion for the ocean, and maybe she will talk about that later on, into action. She is part of the UN Action for Climate Empowerment, ACE, and she's part as well of the Global Center on Adaptation and for the Youth Advisory Panel, but I'm sure she can explain that much better. So she's part of a lot of different committees that I guess talk about climate change and how we can get ready, mitigate, but as well adapt to this impact that Dr. Francis just talked about. So let me just sit. I just wanted to start this discussion. I have some questions, and then we can get to the audience, because I'm sure you have a lot of questions. But Ms. Shaemma, I wanted to know and to understand exactly what you're seeking about. Well, you have a lot of experience with the action for climate empowerment and youth commission and so on. And how does that translate to the youth of the UAE here?
Thank you so much for the questions, and thank you for inviting me to be part of this panel discussion. So essentially, ACE is a very light-hearted topic. It's not the typical when it comes to climate change. It's very doom and gloom kind of thing. ACE is more like, okay, we have a problem, what's the solution? And we recognize that the solution lays within the community, so the society. So Action for Climate Empowerment operates under 6 principles. You have education, access to information, international cooperation, training, and there's one that I have forgotten, but there are 6 principles. So the 6th principle essentially supposed to guide the country as to what are the most optimal way where you can integrate community and society in action. Because you hear a lot of the time where youth are very excited, they have the energy, they have the capacity to be able to help the country with their movement when it comes to climate change. But a lot of the time they don't have the direction or the means and the ways how to do it. So ACE gives them that guidance for them as to what are the gaps, what you can do, and how you could help your countries to able to achieve that. So when it comes to the UAE, we're currently in the process in terms of developing our first ACE framework or strategy. And this strategy or framework will be the umbrella where we're housing all of the different initiatives, all of the different policy strategies that the UAE is working on, targeting society and adaptation under it. So it gives us a broader kind of direction what to do. Again, so for the youth, we recognize that they're doing a lot and we want to give them that direction. For instance, we know a lot of the youth that approach the ministry are requesting a lot of data information. So that's one of the parts of the things that we're trying to facilitate. How do we facilitate the most appropriate way for them to have access to those information in order for them to do their research papers, in order for them to do their own projects and initiatives. So that's one of the ways that we're looking in terms of doing with ACE.
Great, that sounds like very interesting. So just how much do you think the youth in the UAE is involved or is interested in being part of the action?
I think the thing is, they are already involved. It's just the term is not being coined a lot. It's not being used a lot, but they are doing quite a lot already when it comes to ACE, right? For instance, we have a lot of youth circles, perhaps championed by the Youth Federal Authority. We know there's a lot of research institutions out there that are supporting the youth. One of them is CCRN, which is Climate Change Research Network. Dr. Diana is part of it. And we have already opened a division dedicated for the youth. We're preparing them to be able to do research paper, how to research, how to conduct scientific evidence, and how to help us to make sure that our policy is evidence-based. So what they could do essentially is us supporting them more than ACE, like them helping ACE, if that makes sense. So ACE will give them the direction, and through that direction, they will be able to conduct the best initiative on ground to support their own project, to support the country's project. So we have a lot of education-based initiative, similar to what you're doing here with the science talk or climate talk. So what we're trying to do is, how do we make sure that a lot of those education-based initiatives actually produce the outcome that is desired, right? How do we measure that they're able, that they have gained the knowledge that is necessary for them to use it as a tool later on? Like, how do you create the expertise in the UAE? Like, we want climate experts, we want adaptation experts, we want mitigation experts, and we do recognize it starts with education. We gotten a lot of interest in terms of youth telling us, we don't have a curriculum regarding climate change in the UAE. So this is one of the steps where we want to combat, right? So how do we make sure that we prepare the most appropriate education curriculum, climate change education in the different university, in schools? So we are currently in talks with the Ministry of Education in terms of how do we tackle that? What should we do? And all of this will be housed under ACE and also our National Adaptation Plan. So we already have we're building our first national adaptation plan, and hopefully during COP we'll be announcing our roadmap. So one of our targeted sectors is education, because we recognize it plays a very integral part in preparing the workforce, in preparing the next generation. They need the knowledge to be able to do what's necessary from their part, recognizing that they will carry the responsibility later on.
Yeah, a big program, indeed. Thank you for that. Just, Dr. Francis, obviously we know that there is a large range of action, and you were talking about that in your talk, at different scales, coming from different entity, government, private sector, and communities. But what would be, in your opinion, the number one priority initiative for the communities in the region?
Yeah, it's important actually to set priorities, because when we have a lot of options, we lack to take action. So priorities are important. I think the main action that really need to be rolled out very quickly is energy transition, meaning that in all aspects in our life, we'll be relying less on the fossil fuels. And this is happening already in the UAE. Today, actually, the data were out from the International Energy Agency. And the UAE is the first country worldwide that actually now is having the contribution from renewable energies is the biggest to the national grid. So this is very good and can be, an example to other countries as well. Luckily, we have the solar energy here. We do have also recently the nuclear power plant that is helping in reducing the reliance on fossil fuels. In terms of actions for the communities, the most important is actually the waste issue. Reducing waste that is coming from any source, so food waste, plastic waste. Why? Because this waste for now is actually ending in landfills. And when we look into landfills, or when we look into greenhouse gases, especially methane, for the UAE and for the Middle East, the hotspots that you see in methane are coming from landfills, because these are waste that is left in the nature, and they will, some bacteria will form, and they will emit a lot of methane until they are completely degraded. So waste is really something to be considered.
Yeah, I would not have thought about that, but yeah, indeed, waste and methane, it's very much related. Thank you for that. Another question for you, Ms. Shaemma, before I leave the floor to the audience. Just obviously COP28, so the Conference of the Parties is coming to Dubai. Do you have any expectation from this COP for the youth of the country?
Sure. COP has a lot of expectation. Again, it's the end of a journey, beginning of a journey. It will give us the direction as to what should we do for the next how many years left, right? So one of the expectations behind COP28 is the global stocktake. So the global stocktake essentially will be the document that will give us the insight as to where we are currently, what are the gaps, and what should we do to make sure that we are able to commit to our Paris Agreement goal, right? Being below 1.5. So in terms of youth, and both globally and in the UAE, that document will give us kind of direction to see how have the youth impacted, how have they supported the action, and what should they do next. It's an opportunity for them to kind of read that document, dissect that document, and see where they could play a part in it. And then especially when it comes to like agenda items, for instance, adaptation and ACE, Action for Climate to Empowerment, those are where the youth can kind of grab that opportunity to say, I can do here, I can support in this term, and this is where we could do. So COP will essentially be for all of the youth that will be able to participate in COP, an educational opportunity for them. It's a network opportunity for them. It's for them to collaborate with other, let's say, global North, global South youth. Is to hear the different perspective. And from that, they could formulate their own strong, let's say, action later on that they could implement in ground. It's an opportunity for them to engage in different perspective. There's 2 pavilion that I would recommend for the youth to participate in. This will be the second time for us to have children and youth pavilion. And this is where you can hear the different perspective, is to listen in, is to learn, and see how you could later on implement some of those projects on ground. And another one, which is green education, because we do recognize education plays a huge part. So there's a lot of already programs set in place in both of those pavilions, targeting children, youth, people of determination, or people with disability, elderly, the different parts of community. So I think attending those the 2 pavilion and also the youth pavilion, please do join us. You'll hear and see a lot of different projects. You will hear about a lot of initiative, and this can guide you later on once we have the global stocktake. Again, the global stocktake is not necessarily will give us like a groundbreaking result. It's a result that we know. We know we're not moving in the trajectory that we have. We know we're extremely behind. So it's a way for us, it's like, okay, this is not being fixed. How could you help? And it will be quite interesting to see the global stocktake, how they will round up the effort that the youth had done and what measures they will give the youth to be able for them to continue their journey.
Okay, nice tips for the pavilion. Thank you. All right, I guess we can get question from you in the audience. All right, here.
Okay, thank you. Hello. So first of all, I want to thank you very much for your very interesting and inspiring talks until now. I just have a quick question about the presentation, Dr. Francis. It was really interesting to see the flooding maps of the Middle East and the Gulf. And maybe it's a question to all of you, but how do you think will this impact Abu Dhabi in terms of city planning, in terms of society, in terms of how the urban realm will look like in the future? Because it was not only for Abu Dhabi, but generally it was quite hardcore.
Thank you for your comment, and indeed this is something that actually should be integrated into the future urban planning, and the ministries that are actually give, for instance, the construction permits and the design of any construction that is going to happen in order for it to be adapted to this change that is most probably going to happen. Now, in terms of regulations and policies, I don't have any idea. Maybe Shaemma can help me on this.
Sure. So we recognize that sea level rise is a problem, and most likely the coastal area in the UAE will face the brunt of the impact. So back in 2019, we did a risk assessment for the environmental sector in the UAE. So one of the identified priority for us was the sea level rise. So currently what we're doing, we are updating our risk assessment that we have done previously as we're working on our first national adaptation plan. So we're planning to do a risk assessment, a vulnerability assessment, and through those assessments, it will give us kind of the direction as to how would the sea level rise impact urban development, right? And what are the measures that we should put in place to make sure that the impact is not severe? How do we combat that? How could we, the best way for us to address it? So hopefully, as we're progressing with our project, it will give us a much clearer kind of direction what to do. So that's one of the ways in terms of policy. We do have the risk assessment and we do have the climate change plan. However, the national adaptation plan will be the kind of the base for us in terms of full understanding what is happening and how we could address it.
Thank you. Any? Yes? Here.
Hello. You mentioned the Climate Change Research Center. Can you tell more about this and how to get involved as a student?
You mean the NGS lab at Khalifa University?
Yeah.
Yeah. So basically, we have opportunities for PhD students through the applications of the university. So you can visit the website of the university and look for PhD or master opportunities. And from there, you have to apply, and there is a process, as in any university. In your application, if the climate or the environment is your area of interest, you can mention my name, because the applications will come to each faculty that is handling those subjects. Yeah. In case you are already a graduate and you are looking for a job, basically the job opportunities in NGOs are research oriented. So we have a team of postdocs, meaning person that achieves their PhD and they are working as researchers. We have scientists and we have also some research engineers.
And are there any opportunities for undergraduate students in that area?
As work, no, because to be undergrad and involved in the lab, you need to be a KU student. Okay?
Thank you. Thanks.
Perhaps maybe I could answer that
Yeah,
question.
yeah, as well.
So
Yes.
we have Climate Change Research Network, which is part of the ministry. Dr. Diana is the cluster lead for climate modeling. So we have already opened a division for the youth. If you're from age 18 until 30, you're more than welcome to apply. We did close the application, but if you are interested, we're more than happy to kind of take your interest in. And we are planning to give opportunity to undergrad students, advocates, even if you're not necessarily studying the subject, but you are interested and you're willing to support the cause, we're happy to open an opportunity for you.
Nice to know. All right, we had a question just here. Yeah. Yes. Do you wait for the?
Thank you for explaining, and my question is for Dr. Francis. How do you know that the climate change and in Antarctica and the sea levels and how the molecules, how did you know?
Great question. Thank you. So, yeah, I did not mention in my talk, actually, that all the data that we use in order to know about this information. So the data we use is basically satellite data. That's why in most of the graphs you see the year is starting 1960, 1970. This is when the satellite era started. So meaning we have now a lot of satellites observing the Earth and the different parameters. In addition to satellites that are, over the Earth and they can tell us what is in the atmosphere, we have also measurements at the ground. But these are limited in area because these will measure, let's say, Abu Dhabi, for instance. They will not cover larger area. So, yes, the answer to your question is that satellite data, we call them Earth observations, are really the main tool that help scientists to discover all what's happening to the planet.
Nice question. Yes.
It's okay, I'll take it, it's fine. I want to know, like you said about rising sea levels and with climate change it's making the sea levels rise, would that affect the animals in the sea? Like, would it harm animals? Because I know the animals that live in the coral reef can't be, like, live too deep or live in too shallow waters.
Thank you for this very important question. Yes. You are absolutely right. The marine life will be hugely impacted by sea level rise, not only human, yes. Because, as you know, each species is actually used to some level of water, some areas. These, if the sea level is rising, it will flood other areas, so they will be displaced with the water, and they will find themselves outside of their home. Okay, so yeah, definitely this the impact on marine life is huge. Thank you.
Yeah, just if I want to add to that, it's also the rate it's happening, because some of the animals may move or grow, like the coral reef, just to keep up with the sea rise. But if that sea rise is too fast, then they will not be able to keep up, and then this is where they lose their home. Yeah. At the back.
Hi, hello. Hello, my name is Iman Danish Khan, and I'm 13 years old. So I have a sort of a general question. So as you may know, when there was lockdown for the COVID, so there was a dip in the demand for like driving cars, so less fossil fuels. So first of all, do you have any data for that? And regarding that, since it was like obvious that it had like there was more, you know, so do you think that there should be like a few days, maybe like something like a solution, like a lockdown that could help, you know? So because when in COVID there was like a drastic increase of, yeah, so do you think, yeah?
Okay. Thank you for your question. Indeed, after COVID, we can think about this type of solutions, but unfortunately, I don't think this can work for the reason that, as I said, the lifetime of greenhouse gases is 100 years and above. So in order to see any difference in this, you need actually to stop the activity of this order, and this is a huge meaning that you no more life, right? That's why a transition is needed, not stopping the current work that we do to live, everyone in our societies or work. Or now your question regarding during the COVID, what it changed? Okay. It's true that we saw a decrease in the level of pollutant. When I say pollutant, these are pollutants that are, I show in my graph, they appear in the blue. These are aerosols. Their lifetime is hours or weeks. So yes, during 2 months of lockdown, it was evident that these pollutants were decreased, but little was happening to the CO2 and methane and all the greenhouse gases.
If I could just add to that, we did recognize as a ministry the dip, but similar to what Dr. Diana was saying, the dip wasn't the emission, it was the aerosols or the pollutants. We're not planning to do lockdown, we don't want to anger people, but we are kind of seeing what's the best way to kind of emulate what happened during the lockdown and how the best way to approach it. So part of our adaptation work, we are kind of studying in terms of increasing public transportation, increasing EV, for instance. How do we encourage people, to, for instance, to walk instead of using their vehicle, or to cycle? So there's a lot of initiative currently undertaken to change the infrastructure to be able to accommodate walking, cycling, like scooters and stuff like that. And another plan is like to change the infrastructure to be able to accommodate a lot of public transportation, for instance, train, EVs. We have more than, I believe, like we're increasing our EV charging station, and then the country is also supporting people that are planning to buy EV cars as well. So there are plans set in place to kind of, and hope to emulate what happened during lockdown, but not lockdown.
And if I may add as well, I guess also it's every one of us during lockdown, we kind of saw the priority, or we had the bare minimum, or we had, so maybe we personally can make the decision, or take the decision to just reduce the things that are not that useful for our life and that may be contributing to CO2 emission a bit too much. So yeah.
Exactly what you're saying. So when it comes to adaptation in both A's, we recognize that consumer behavior plays a big part. So the country can put legislation, laws, and strategy, but if the people are not implementing some of them that are pertain to them, their own behavior, that you wouldn't see any progress, right? So we can build the infrastructure, but if people are not willing, for instance, to walk or cycle or use the EV, then technically the project did not succeed. So the responsibility is not only on the government, but also on people as well. So once you know that there's a specific policy out there, it's best to kind of see how you could, from your own responsibility, to be able to help the project.
Yeah, thank you. We have a question here, and then after that. Here, yeah.
So, is there a way to like remove the greenhouse gases from the atmosphere?
Great question. Thank you so much. Yes. So actually now engineers and scientists are trying to find a way to remove the CO2 especially from the atmosphere. And it's not yet operational, meaning that we are not yet at the technology that we can implement at large scale in order to remove it. But a lot of work is being done, especially at universities where this kind of ideas is actually taking place, because this is indeed will be very important for the coming decades to remove the excess of CO2 and other greenhouses from the atmosphere. Thank you for this nice question.
Yeah. Sure. So from the minister's perspective, in terms of removing, we do recognize there's removing and also replacing. So in terms of replacing, we're trying to encourage using renewable energy and kind of remove from the traditional fossil fuel energy. So that technically will help reduce emission in the atmosphere. And another one similar to what Dr. Diana was saying, there's a lot of innovative technology out there. Some of them are still not operational in terms of carbon capture, but there's a lot of study as to how we could implement this. And one of them is not like a technology, it's a nature-based solution in terms of removing emission from the atmosphere. Here in the UAE, Brian, I'm looking at you, they're planting a lot of mangroves. So mangrove is a natural way for us to remove CO2 from the atmosphere. That's hence why the UAE is planning to plant more than 100 million mangrove in the next, so how many years? I believe until 2030, if I'm not mistaken. So this is one of our way to kind of push the idea of removing carbon capture, because it's a natural way of doing it.
Thanks. Thanks for the mention of that. Yeah. You had a question? Yeah?
My question is, what are your opinions on geoengineering?
Okay. Thank you so much for this question. So geoengineering is a engineering of the climate, meaning that we can do it in several ways. We can put some satellites in form of mirror to reflect the sunlight back to space before it reaches the ground. We can do it also by injecting SO2, which are aerosols that themselves reflect the sunlight back to space. We put them in the stratosphere. It's like simulating a volcano eruption, but made by a human. This is the second way. Third way that is also studied by scientists is to produce more aerosols from the sea to actually brighten the clouds over the oceans. Again, the idea is to reflect the sunlight back to space. A lot of research is being done around these three methods of geoengineering. Now, I think the most important aspect that is holding us from stepping into this area is ethical, okay? Because why, for instance, one country has to decide about the fate of the others, where you will put this satellite, over which area, where you will inject the sulfur dioxide. So, and the other aspect of it is the risk that we don't completely know what could be the risk once we do this. What are the results? Because we don't know all the processes yet. We know a lot, but we don't know if actually we change something into the climate system, what could be the effects, and maybe some of them are negative. For example, I was involved in one of those projects back in France to study geoengineering and how it will impact the precipitation patterns, so meaning how the precipitation and the rainfall will change if we do this. And we found that, for example, the rain in Africa will be decreased. Even if we are not putting anything over Africa, we are putting it over the Arctic or the... So it's really a system that has a lot of processes that are interrelated and that they feed back in each other's.
Yes, of course. Cool.
Not only you know how you said like simulating volcano eruptions, like releasing sulfur dioxide, like the other types of geoengineering, like seeding the ocean with algae seeds.
I did not understand.
Seeding the atmosphere?
The ocean.
The ocean with algae, so increasing the production of algae in the ocean. Yeah.
Yeah, I don't know, could be, but I mean, all of these solutions, they have, the limitation to be scaled up. We are talking about ocean. You can imagine the size. So how big the area you can cover with this technology is very, very limited compared to the size of the ocean.
And I guess to add to that exactly what you were saying is that you may think you're changing one thing or improving something, but then it will impact a lot more components, and especially if you start playing with the food web in the ocean, adding more phytoplankton than it should, then what's happening to the rest of the animals living in the ocean? This is something that you cannot control. Once you start it, it's just too late. So I do think personally that it's playing magician might not be the best way to go. All right, another question? So over there, yeah.
Thank you. Hi, my name is Kodai. I want to know if there's a way to control dead zone, or if there are any ways to bring a dead zone back to life.
Yeah, very good question. Thank you. To date, no. The short answer is for now, no. Although there are a lot of research around this subject, because as you can imagine, this is a big issue. And the dead zone around the globe, they are growing. So scientists are trying to find a way to restore and limit, at least. So yeah, a lot of research I think need to be done in this domain, because these are specific to each region. So meaning something we can find for, let's say, the dead zone in the Gulf of Mexico may not apply to here, because the characteristics of the water are different. Here is very shallow, very saline, very warm compared to there, although they are both in the tropics. But each area is specific in this regard. And a lot of research is needed actually to understand better how this is working.
Thank you.
So you spoke about precipitation. You think we have higher precipitation here now, or increasing precipitation, I would say, for Abu Dhabi? We cannot say it, maybe for the mountain areas. But as far as I know, the data are not indicating it yet. And which shifts do you expect for the monsoon belt, as we had in the history? So what do you think will happen there?
Yeah. You know that the UAE sits on the band that we call subtropics, but really on the lower band of the subtropics, so bordering the tropics. Several papers have been published in Nature and other journals pointing out to the fact that global warming is making the tropics expanding. What does it mean? It means that more area covered with clouds are appearing in satellite observations, for instance, and more rain is produced from these clouds. So because UAE is in this band, it's quite possible that we cross this line, that meaning that tropics can advance toward the UAE, especially from the south. Now, regarding the past data, the graph that I showed with increased precipitation, it's true. This study was done over all the UAE, not only per city. It's over all the UAE using satellite data again. And for the spring season, we found this increase in cloudiness first, not any type of clouds, the convective clouds, those that they will give rainfall.
Add to that question to you, but how do we differentiate if the increase in precipitation is natural and not due to the fact we're doing cloud seedling? Like, can we differentiate if the increase is because of, is it natural or is it seed?
Yeah. So again, the intervention with cloud seeding is really very localized, because you can imagine that the pilot that is, seeding the clouds, he cannot cover a very large area. So our first criteria to, separate these two is the existence of cloud, because if there is no cloud, they cannot seed. They cannot create cloud themselves with cloud seeding. So we need the cloud to be over the country in order to enhance the precipitation that comes from it. So the presence of clouds is increasing. And then we rely also on the fact that cloud seeding can really have very local effect, because they cannot cover very large area with the airplanes that usually are in use. So we think that it's mostly natural.
Great. Maybe one more question, and then we will close the,
Hello, hi. Thanks for the talk, Shaemma and Dr. Francis. So my question is about the slides, Dr. Francis. So I'll start with the one that's similar to Claudia's. It's about the rain. So it said 50% increase in precipitation. So I was thinking, would that have any negative feedback loops when it comes to climate change, increases in temperature? Just thinking about increase in vegetative cover, and so any thoughts on that, or maybe if there's research on it? And then just the second thing, if you could maybe explain a little bit about why on the map, the world map, some areas had a higher increase for temperature. So why that is. So for example, we saw Arabian Peninsula was more red than North Africa, and so yeah, thanks.
Thank you so much for both questions are very interesting. So for the first question, the 50% increase in precipitation, these are projections between 2050 and the end of the century. And these are expected to give positive feedback, not negative feedback on the temperature, meaning that they can reduce actually the temperature that is expected over these regions. Why? Because when you have, let's say, rain, you expect that the green areas will be increased, and this will freshen the air. So hopefully this is good news, I think, for the southern band of the Arabian Peninsula. But of course, adaptation measures need also to be account for this, because if a lot of rain is coming, but then it's going back to the sea because no drainage system or we don't benefit from it, then again we need adaptation. Regarding the second question, which was about the regional change in temperature globally, this is mainly related to the fact that some areas are surrounded by oceans or seas, others are more isolated. So North Africa, for example, it has a Mediterranean Sea that can contribute to lighter, let's say, increase in temperature, as well as the Atlantic Ocean, because they absorb the heat. Whereas here we only have, the Red Sea, the Arabian Gulf, so it's less, protected by the seas than other places.
All right. Well, thank you, ladies. This was a very, very interesting evening. So thank you for responding positively to our invitation. I hope you enjoyed the evening and learned a bit more. I would leave you to that. And next talk on the 14th of December, and we will be talking about something very different, about cuttlefish. So please come to discover the great world of cuttlefish. All right, thank you.